My name is Tom, and today I'm going to be using the Delta Electronics temperature controllers. That's the DTC 1000 and 7 DTC 2000s. And I'll tell you a little bit about the controller real briefly. The DTC 1000 is the main controller in the rack, and a rack consists of 8 controllers, 1 DTC 1000 and 7 DTC 2000s. You can make the rack smaller, but it's not advisable to make it larger because of the power budget of the DTC 1000. It's DTC 1000 is the one with the run-stop switch on it, and the 2 plugs on there, one for power, one for communications. You can use this to communicate with PLC or HMI. So I'm going to scroll down a little bit here and show you my material list. And on my material list I also include hyperlinks so I can go directly to the website and pull up manuals, software, firmware, wherever I may need. So my first website is going to be the Delta Electronics Incorporated website. And if you followed my link or typed it in, you should be at this page right here. And if you scroll down a little bit to the download section, you can see that you can download the manuals and the software. Here we're going to double click on the software, and that brings up this web page. And the software that we will be needing for this application is going to be the top one. It's the DTC OM software. Next web page I want to go to is the B&B Electronics web page, and that's for the USB serial converter that we use. And I'm going to scroll down a little bit here. I have the serial converter already highlighted that we will be using today, and that is the 485 USB 9F-2W-LS. If you come over here, you can download the PDF of the data sheet, or you can check out a picture of it. So now I'm all done with the websites. I'm going to come over here and I'm going to show you, I'm going to scroll down a little bit, and I'm going to show you the pinout of the converter. And yes, that is A negative to A negative and B positive to B positive, all jumpered. So I'm jumpering A negative to A negative and jumper B positive to B positive. And out of B positive, I'm going to the positive on the communications port of the DTC 1000, and the negative goes to the negative on that port. I'm all done with my setup sheet. I'm going to open up the software here since it's already on my desktop. And this is what the software looks like. It's nothing elaborate, it's no real big download. So I'm going to come up here to the set button. I'm going to click on that. And the first thing I want to bring to your attention is the COM port right here up at the top. You can see most of them are grayed out, but for me 2 of them are active, and the one that is set is COM 6. And if you're not sure which one your USB serial converter is plugged into, you can come down to Start, go to Control Panel, and you'll be looking for Device Manager. So you need to go to Hardware and Sound, Device Manager, and I come down to Port, double click, and I'm using COM 6. That's okay. Exit out of that, go back to the software. So the next thing I want to make you aware of is the baud rate, parity bit, data length, stop bits, and format here. The only thing I want you to do is make a mental note of where these values are actually set, or you can jot them down or do a print screen, because this is actually pretty important and a little bit later. But I'm going to come down here to Auto Detect, and I'm going to click on that. And since I know that I reset these temperature controllers to the factory default, I'm going to set that up in this area right here. Now if you're unaware of what your settings are, or you're not sure of a setting, you're best off leaving it as unknown. If you leave them all unknown, it could take up to 1 hour and 7 minutes to scan. So if that's the case, you need to go grab a lunch or a cup of coffee or something and just wait until it's done. May be done sooner, but it may take the full scan. It's hard to say. So what I'm going to do is I'm going to plug in them values. Since I know that it's controller number 1, I'm going to go 1H, 01H to 1010. Well, that would be 10H. The baud rate is going to be 9600 bits per second. The protocol is going to be ASCII. And the parity is going to be even. Now when I click start here, what's going to happen is you're going to have a bar that comes across here, and it's going to go across. That's the percentage of the scan. And just down below it is going to be the time left of the scan. And when I hit the start button, you're going to see on your controllers the RX and the TX lights start to flash. And when it makes communications and it verifies it, it's going to start populating this field here. Now I'm expecting to see 1 through 8 controllers. Now I'm going to press start. And then scroll across and the field is populated. I can hit cancel and that will stop this. It will stop the scan. Or I could have just let it play out all the way. Next thing I'm going to do is, you see this set button down here is not active. It's grayed out right now. I want to come up here to where it says 01H, and I'm going to click on the communications protocol area here on the first one, and that took the gray out of here. Now this button is active. What this button does is it takes the protocol here and it saves it. And let me show you where it saves it. First I'm going to hit set, then I'm going to close this out. And what it did is it saved it in through here, which is actually pretty important, and you'll see why in a few seconds. But here I want to click OK because I want to save all these values. If I hit cancel, it will go back to where it was. So I'm going to click OK. And I'm going to come here to VTC Set. Now that also sets it here and here. These values up here we want to leave alone, because that is what is in the controller right now. These values down here are the ones that we want to change. As it says, set to DTC. These are the values that we want to put into the controller. So the address I want to start at 1, but the baud rate I want to move to 19.2. Bit length I'm going to leave alone. I'm going to change the protocol to RTU. The stop bits I'm going to leave alone, and the parity I'm going to change to none. Next thing I'm going to do is I have a box down here, and I'll place a check mark in it. And what that is for is it's going to auto synchronize the communication protocol bit inside the DTC 1000. It's going to set that on so that when I connect this temperature controller to the rest and I power it up and power it back down and power it back up again, it's going to write that communications protocol to all of them controllers, and it's going to put it in, and it's going, each controller is going to go up 1 address. So the second one is going to be, the address is going to be 2, 3, 4, 5, 6, 7, and 8. So another thing that's going to happen is it's going to start scanning across, and then your LEDs are going to flash again, and you're going to see a banner come across here, and the last one is going to say that the auto synchronization has completed successfully, and you need to power down the controller, reconnect the other controllers, and power it back up, and that will write communication protocol to all of them. So I'm going to click set here, and there's my banner. Now I'm going to click close, and I'm going to power down and power back up my controller. They were already connected together, so I didn't need to put them back together first. And I'm going to come over to this third button right here. I'm going to click on it real quick, and I'm going to show you something. And I'm going to connect to it, but it's not going to be able to connect. And here's the reason why. I'm going to X out of this. I need to come over here to the set again. And what we did is we changed the communication protocol for all of them controllers. And we did not change this. We need to change all of this again to match what's in the controller now. This is the old communication settings. We need to put the new communication settings in. So we need 19200 bits per second, parity of none. We'll leave the data length at 8, stop bits at 1, and format is going to be RTU. Now we'll click OK, and that will save them settings. Come back up here, click on our controllers, and you can see the controllers are communicating. You have values in the field, and when you look at your temperature controllers, you should see the RX and TX LEDs flashing for the first four controllers. On the next four controllers, only the RX LEDs are flashing. Okay, we're connected with our controllers, and for our application in thermoforming, we typically use these in thermoformers and extruders. What we are going to do is we're going to set these up, and there's a couple of different settings that we can use on here, and we can use it for PID, on off, manual, and ramp soap. We use PID, so we'll leave it for PID. Here we can select to run the controller, stop it, stop the program, or hold the program. We just leave that alone, just leave it in run. And output 1 we typically use for heat, but we can use it for heat, cool, alarm, and retransmit. So we'll leave that at heat. Output number 2 we can set for cool, heat, or alarm. We'll leave that at cool. But let me show you what happens over here on the right when we press alarm. The alarm area opens up over here. It's no longer grayed out, and we can choose a host of different types of alarms. So be aware of that. So I'll go back to cool. Lock status, we leave at normal, but you can set it for locking all or not the set point. But it'll lock everything else but the set point. So we'll just leave that at normal. From this software you can actually auto tune also. Now if you look up here, there's a little gray area. I don't know why this is over here, but this software, this should be over in here. But I'll click here in the drop down box and press start, and you'll see this little LED flashing here, where actually you should, and that's because I'm not connected anymore. go. Let's go to start. And there's my LED right there. And go to stop, and it goes off. Typically for our application, the input type, the sensor type is going to be either a K-type or a J-type. We use J-type on the extruders and K-type on the thermoformers. Now there are 18 different sensing devices you can use. Let me make you aware of this little fact real quick. When you have an out of the box temperature controller, and you'll look up in here where it has PV, that's process variable, it says no connect. Well, that doesn't mean that you're not connected to the temperature controller, because you can see all this field here, so obviously you're connected and you're green here. What that means is that it's either one of two things. You either have the wrong input sensor on there, or you have your thermocouple has come unplugged, or the plug has pulled out from the controller. Or you could have a malfunctioning controller. But if you have this up there, odds are you have an error, the red LED under error on, so you'll know ahead of time anyways. So I'll go back to K-type here, and you can see the temperature comes back up. Units of measure, we use Fahrenheit here, but there are a couple of different units of measure that you can use here. Here you can change the set point. Here's another thing I want to make you aware of, so that if you're using a HMI or a PLC to communicate with this area here, high range and low range, you want to leave as a read only. You only want to read this value. You really don't want to write it, because this is the, if you change thermocouple types, you'll see the value changes with thermocouple type, along with if you change from Fahrenheit to Celsius. If you go back to Fahrenheit, go back to K-type. So you don't want to write to that area, because if you make a mistake, you're going to have an error on the module. So just make that a read only if you're going to read that. The pointer down here is the decimal point, so we can have either 1, 2, 3, or none decimal points. No decimal places, I mean. So let's leave it as, put it as none. As you can see, it rounded the temperature up on both the set point and the process variable. Go back to and put it to 2. Let's see, we're at 39.99 degrees now as a set point, and we'll put it back to 1. Here we change the PI. We can change the PID loop here. A few things that I recommend changing though is the control period on 1 and 2. If you are programming something that has a large mass, like a extruder, the barrel zone on an extruder, the control period needs to be longer. You can set that at 10, 20, 30. But when you're looking at thermoformers and the heaters are connected directly to, or the thermocouples are connected directly to the heater, you need to put that value down. We'll say like a control period of 3 to 7. And that should give you fairly good control over the heating elements. And basically that's about it, all I'm going to go over in this program. I've showed you how to establish communications, how to change the communications protocol, and how to monitor the temperature controller, and how to change some of the parameters. My other videos go a little bit more in depth on HMI and PLC control of these controllers. I also have videos on different PLCs, communicating with drives, motion control, servo control, and I will be releasing them soon. So if you like this one, stay tuned, and I should be posting them shortly.